Good morning everyone. My name is Vivek and this is my video on boards and streams. Boards and streams a very important topic for students who are preparing for placements and also for students who are doing their higher education through exams like GRE, CAT and MAT. So let's get into this video. Firstly, let's consider we have a river which is flowing like this, which is a free body which is flowing like this. And if we place a boat, a paper boat on top of it, we place a paper boat on top of the river, and we know the river is flowing in this direction. We have a boat on top of it, and if this is a paper boat, if this boat is a paper boat, and we have river which is flowing in this direction, what direction will the boat flow now? The boat travel now? We know since the water is flowing in this direction, we can also assume the boat also can go in the same direction of the river because it doesn't have its own velocity. So it doesn't have its own velocity because it's a paper boat. So we can very easily assume the boat can also go in the same direction of the river. Now, if we have add another point to it, if the river is traveling at 2 kilometers per hour, the river speed, the flow of water in the river is 2 kilometers per hour. The speed is 2 kilometers per hour. And if this boat is placed on top of this river, and now we could very easily say the boat can also travel in the same speed as the river. So if that goes in that speed, the boat speed right now would be 2 kilometers per hour because it's a paper boat. It doesn't have its own velocity, so it can go in the same speed of the river. So it's 2 kilometers per hour. Now, if I add another point to it, that is, if this boat is replaced by a normal boat or an original boat which can travel at 10 kilometers per hour, which can naturally travel at 10 kilometers per hour without any support of river or anything. If it can naturally travels at 10 kilometers per hour at stationary water or still water, water which doesn't have any movement, this boat can travel at 10 kilometers per hour. If this boat is placed on a river which is traveling at 2 kilometers per hour, now what will be the speed of the boat? And we know the boat can actually go at 10 and the flow of water is going to be at 2 kilometers per hour. Now the boat will travel at 10 plus 2, which is nothing but 12 kilometers per hour. It will travel at 12 kilometers per hour, and this speed is termed as downstream speed. They term this as downstream speed. Downstream speed, reason being it is traveling in the direction of the this is traveling in the direction of the river. The boat is traveling in the direction of the river, so it goes along the river, along the flow of the river. So that there we just add both of the speeds. It's going to be 12 kilometers per hour. Now if the same boat is placed in the same water with a small difference, that is, if the boat is traveling in this direction, the boat is traveling at this direction, that is in this direction, and the river is flowing in this direction, and the speed of the boat is 10 kilometers per hour. Now what happens is the flow is towards this direction, towards the right, and the boat is traveling towards the left. And we could very easily see here the boat has to travel a distance by going in the direction opposite to the flow of the river. Here what happens is anything more than the speed of the river will be able to move the other side. If both the boat as well as the river is at 2 kilometers per hour, we know there'll be no movement in the boat because the river will not allow the boat to move. Now, since the boat is going at 10 kilometers per hour and the river's flow is 2 kilometers per hour, since the boat is going in the direction opposite or the against the flow of the river, now we could very easily say the speed of the boat is going to be 10 minus 2, it's 8 kilometers per hour. This is termed as upstream speed. This can be very easily termed as upstream speed. Upstream speed. So we know downstream speed is going to be 12, and we know it's still water. The boat speed is going to be at 10, and upstream speed is going to be at 8. So it's very simple, the same procedure. We have 10 is still water. 10 minus 2 gives you 8, which is your upstream speed. The same 2, the stream speed of 2 is added to still water, gives you downstream speed, which is 12. A very simple technique. The stream speed is subtracted when it's going upstream. The stream speed is added when it's going downstream to the still water. So still water speed, the boat speed in still water is 10, and with that the 2 kilometers per hour of the stream is subtracted for upstream speed. 2 kilometers per hour is added for downstream speed. So it's 12 kilometers per hour. A very simple technique which makes our life easy. All that we have to do is just add it on one side for downstream and we have to subtract it on the other for upstream. A very simple technique. So with this technique, we're going to solve some more problems. So let's take for an example another question. If we see the downstream speed of a boat is 7 kilometers per hour and we have upstream as 3 kilometers per hour, then what will be still water speed? We know still water here has been 12, downstream is 12, upstream is 8 and still water is 10. So very obviously we could say 12 12 minus 2 gives you 10 and 10 minus 2 gives you 8. And very easily we could say adding downstream and upstream we get 12 plus 8 is 20. 20 divided by 2 is 10. The average value has always been the still water. Average is always been still water. So 7 is downstream, upstream is 3, and we know still water is always going to be the average of both of this. So or the middle value of these. The middle value of this is going to be 4. It's very simple. So the value for this is going to be 7 and 3. I'm sorry, the still water speed is going to be 5. It's because 5 minus 2 is going to be 3, which is upstream, and plus 2 is going to be 7, which is downstream. The 2 kilometers per hour is going to be the stream's speed. Okay, a very simple technique. This is how we're going to solve these questions. Next on. So let's get on to some problems. So we look at a question here. A man's speed with the current. With the current can very easily be told as downstream speed. So downstream speed is given as 20 kilometers per hour. 20 kilometers per hour. And the speed of the current is 2.5. Speed of the current is nothing but the speed of the stream. So speed of the stream is 2.5. And the man's speed against the current is. The man's speed against the current is the question. You know, downstream is 20 and 2.5 is stream speed. Then we'll have still water, we'll have upstream. They're asking for against the stream. Against the stream current or against the stream, it's talking about upstream. So we know downstream is 20 and 2.5 is the stream speed. We know downstream is the stream speed adding to the still water. So very easily, if it is not added, it will be the still water speed. So we know stream speed is 2.5. We know downstream is 20. The still water will be 17.5 kilometers per hour. A very simple question. And now again we know upstream is going to be what? The stream, the boat on its own will, if it travels, it goes at 17.5 without any support. If it has to travel against the flow of the water, you know, against the flow of the water, the flow of water is 2.5. So upstream speed will be 17.5 minus 2.5, which is nothing but 15. So upstream speed is going to be 15 kilometers per hour. A very simple question. This question can be solved at practice in less than 10 seconds or even 15 seconds time. A very simple question. Yeah. So let's get on to the second question. In 1 hour, a boat goes 24 kilometers per hour along the stream and 16 kilometers per hour against the stream. The speed of the boat in still water is. So it's very obvious a boat goes 24 kilometers per hour along the stream. Along the stream says it's downstream. Downstream is 24 and they've told 16 kilometers per hour against the stream. Against the stream is upstream, which is nothing but 16. Is asking for the speed of the boat in still water. Still water is what is asked for, and we know still water is always going to be the average. So average of these both is 24 and 16 is going to be, it's 24 minus 4 gives you 20, 16 plus 4 gives you 20. So it's nothing but 20 here. Minus 4 gives you 20, and this when you add minus 4, we subtract minus 4 gives you 16. So it's a very simple technique, or else 24 plus 16 is going to be 40. 40 divided by 2 gives you 20, because still water is going to be the average. The boat speed of the boat in still water is going to be average without any support of the stream. That is very obvious here. So 16 plus 4 gives you 20, or else 20 minus 4 gives you 16. A very simple question. So next question. If a man rows at the rate of 9 kilometers per hour in still water, the question says a man rows in still water at 9 kilometers per hour and his rate against the current is going to be upstream. Upstream speed is going to be 5 kilometers per hour. The man's rate along this current is asked for downstream. So we very easily know still water is 9, upstream is 5. So which means minus 4. 9 minus 4 gives you 5, which is the stream speed is subtracted from still water. So we get 5. The stream speed should be added for downstream. So it's nothing but 9 plus 4 is going to be 13. So your downstream speed or along the current is going to be downstream is going to be 13 kilometers per hour. A very simple technique. Again, this question gets solved in less than 10 seconds time. A very easy technique. So next question. A boat goes 6 kilometers against the current of the stream in 2 hours and goes 1 kilometer along the current in 10 minutes. How long will it take to go 9 kilometers in stationary water? So we'll go one at a time. The boat goes 6 kilometers against the current in 2 hours. So the boat goes against, which means upstream. It goes upstream. They say it goes 6 kilometers against the stream in 2 hours. So for 6 kilometers, it takes 2 hours. So its speed is going to be 1 hour. How much does it travel? For 6 kilometers, it takes 2 hours. For 1 hour, it travels how much? Just a cross multiplication. We could very easily say upstream speed is going to be 3 kilometers per hour. A very simple technique. Now, downstream is going to be 1 kilometer for 10 minutes. So downstream is going to be 1 kilometer for 10 minutes. So it's given in minutes. So for 10 minutes, if it goes 1 kilometer, then speed is going to be for 60 minutes or for 1 hour. So 60 minutes is going to be just cross multiplication. Your value is going to be 6 kilometers per hour. So very easily we could say downstream is 6, upstream is 3, then still water would be middle of these both. It's going to be 4.5 kilometers per hour. Still water is 4.5 kilometers per hour. So 4.5 kilometers per hour means it goes 4.5 kilometers for 1 hour. The question says 9 kilometers in stationary water. Stationary water is nothing but still water. So still water for 4.5 kilometers still water, this boat travels at 4.5 kilometers per hour. So in order to travel 9 kilometers, how long does it take? So for 4.5 kilometers, it takes 1 hour. Then for 9 kilometers, how long does it take? Just cross multiplication, a value is going to be 2 hours. So it takes 2 hours to travel. So it is a very simple technique. Again, this takes a bit more, but again, a very simple technique. So this can be solved in less than 30 seconds time. So again, I can explain you this concept. Upstream speed is like the boat travels 6 kilometers in 2 hours. In 1 hour, it can travel 3 kilometers per hour. Downstream speed, 1 kilometer it travels in 10 minutes. In 60 minutes, it travels 6 kilometers per hour. So it's very obvious. Downstream speed is 6, upstream speed is 3, then still water speed is 4.5. So 4.5 kilometers per hour for 1 hour, then for 9 kilometers, how long does it take? It takes 2 hours. A very simple technique. The next question. A boat running at 48 kilometers in 4 hours, while for covering the same distance upstream it takes 5 hours. What is the speed of the boat in still water? A boat travels 48 kilometers downstream in 4 hours. So downstream speed would be 48 divided by 4. It's 48 kilometers for 4 hours. Then for 1 hour, how much does it travel? It's very simple. 12 kilometers per hour. It's downstream. So 12 kilometers per hour is going to be downstream speed. So they're asking you the next question. It gives you the next question. It goes upstream 48 kilometers is traveled in 5 hours. Upstream it travels 48 kilometers in 5 hours. So if it travels 48 kilometers in 5 hours, it is nothing but it travels 9.6 kilometers per hour. So upstream speed is 9.6. Downstream speed is going to be 12 kilometers per hour. I'm sorry about this. So downstream speed is going to be 12.6. sorry, downstream is going to be 12, upstream is going to be 9.6. So still water speed. The question is, what is the speed of the boat in still water? The speed of the boat in still water would be the average of these both. So the average of this both will be somewhere in between. I get the value as 10.8. So still water speed is going to be 10.8 kilometers per hour. It's very simple. You could just add both of this and divide by 2, or else you could find the mid value of 12 and 9.6. If I want the mid value, it's going to be 10.8. The difference between 12 and 9.6 is 2.4. The mid value would be 1.2. 1.2 subtracted to this will be the stream speed, and 1.2 is stream speed. Here 1.2 is added. So the stream speed will be 1.2 kilometers per hour. A very simple technique. So next question. Speed of the boat in still water is 22 kilometers per hour. The rate of the current is 2 kilometers per hour. The distance traveled downstream in 24 minutes is. The speed of the boat in still water is given as 22, and the speed of the current is 2. So speed of the current is 2 kilometers per hour. We know if it's 2 kilometers, we know downstream speed is going to be 24, and upstream speed is going to be 2 lesser. It will be 20 kilometers per hour. A very simple technique through which we could get to these questions. The distance be traveled downstream in 24 minutes is. So we know the downstream speed is 24 kilometers per hour. So 24 kilometers it travels in 1 hour. In 1 hour we have how many minutes? So the time that we have is in 1 hour it's going to be 60 minutes. So for 1 hour we have 60 minutes. He's asking you for 24 minutes. How long does it travel? So it's very simple. 24 square, just cross multiply. 24 square is 576. 576 divided by 60. That's your question, and that's the answer. So I very easily can say 57.6 divided by 6. So the answer is going to be 9.6 kilometers. So the distance traveled is going to be 9.6 kilometers. So it's 9.6 kilometers. Again, a very simple technique. So your next question for the day is going to be, a boatman can travel 96 kilometers per hour in 8 hours if the speed of the current is 4 kilometers per hour. What time will it be able to cover 8 kilometers upstream? So downstream speed is 96 kilometers in 8 hours. So it travels 96 kilometers in 8 hours. So the speed is going to be 96 by 8. Downstream speed is 12 kilometers per hour. So it travels 12 kilometers per hour. So downstream is going to be 12 kilometers per hour, and they're asking you for if the speed of the current is 4, what time will it travel to take 8 kilometers upstream? So downstream is 12, and we know current rate of current is 4. So it's going to be still water is going to be 12 minus 4 is 8, and we know upstream speed is 4 lesser than that. So it will be 4 kilometers per hour. So he's asking you how long will it take to travel 8 kilometers upstream. So we know upstream speed is 4 kilometers for 1 hour. It takes 4 kilometers to travel 1 hour. 1 hour. So for 8 kilometers, how long does it take? Answer is going to be 8 by 4, which is equal to 2 hours. 2 hours. Gets over. 2 hours. A very simple technique again. The problem gets over here. It's 2 hours. A very simple technique. Again, this is how you solve these questions. Finally, that is it for the day, and I hope this video would have been interesting and also very useful for you guys to solve these questions at a much quicker rate. And thank you so much for the opportunity. I would like to ask you guys to like, comment, and subscribe my video. And I'll see you guys in my next video. Thank you so much for your time and patience.